Anybody want to raise any question? You can take a short break. You want to go toilet, drink some water, whatever. Yeah. Meanwhile, any question you can ask here in the chat. I already show you the chat, right? What's the time now? Oh, 5:14. That's quite fast. Then, because after this, we will go to the actual practical design. What? No question?
Hello, Mr. Lim.
You are?
Hi, Yandi here.
Yandi Le, is it?
Yeah, hi.
Okay, good. You
Just
need to speak out a little bit louder, sorry. Yeah.
Okay, yeah, sure.
Yeah.
Just a short question on, you mentioned just now.
Let me know your background first. You are?
Oh yeah, sure. I'm actually working in a consultant. I'm also taking a master in NUS.
Okay, you are already, how long have you been working already?
About 5 years.
5 years, okay.
Yeah.
Okay.
Yes, just want to ask your opinion on the transition between from CP4 to Eurocode 7. In CP4, it was quite straightforward. Last time we will usually limit the design to 7.5 MPa, allowable working load, right? But when we go to Eurocode, we know that there isn't really any stress limit. Basically, the the concrete strength, you can actually design it based on the 0.363 or 0.515 FCK, right? Based on whether you are reinforced or not. So the higher concrete grade you use, you can actually have higher so-called the capacity.
Yes.
So what I saw recently is usually the pile will be much longer compared to CP4, and I just want to know your opinion on that, because last time it was quite straightforward, 7.5 MPa, we know the length, but now the pile is stressed much higher actually. Yeah, thank you.
Okay. Good question. But to answer your question, let me ask you a practical question. What is the maximum concrete grade that you can use for ball piles? You are a structural consultant, right?
I'm geotech as well, as in
geotech doesn't matter. This is a common civil engineering thing. What is the maximum concrete grade you can use?
Usually we will use FCU of 40, or I think for board pile, what I've used highest is 50.
50,
FCU,
right?
Yeah, 50 FCU. Yeah.
You use 50 FCU.
Yeah.
Why you want to use such a high grade concrete grade?
In that specific project, the column actually has a very high load, and there is an existing there are a lot of existing piles, so we don't manage to have we need to minimize the number of piles. So I think the QPS decided to use a higher concrete grade.
Yeah. Okay, this is a good practical question. When you use a high concrete grade, you will face problem like retardation, right? That kind of stuff on site, right?
Yes, you're right.
So, and your concrete quality may not able to achieve what you want. Okay, that is a practical concern of using a high grade concrete. Okay, because you are doing this we are casting underground, right? So that's the first issue that we don't use high grade concrete for ball piles. For underground structure, we use slightly higher, maximum usually 35 to 40 for maybe it's actually for corrosive attack, that kind of issue for underground environment. Now, to answer your question, it's not true that EC7 give you longer length. Not true. In fact, EC7, if used properly, can use a shorter penetration length. Okay, EC7 is not. But because you're not comparing apple to apple, you are using a higher structural load now, and that's why you got a very long length, even because you're not capped by the CP4 7.5 MPa. Okay, now you didn't resolve this issue. When you have very long pile length, what is the consequences of using a long, very deep pile length? Do you know what is that? What is the consequences, Andy?
The consequence in terms of what, Mr. Lim?
In terms of your design, what is, because you
I
design
think
it to
it will
satisfy.
be settlement. I think we will have more elastic settlement.
Exactly, you will have more settlement issue, right? You will have more settlement issue. Okay, so this is actually quite common now in the practice. Many structural engineers want to maximize the use of the structural capacity, okay, and try to reduce the number of piles, and the end have a longer piles, and we see a problem that they actually later on fail the settlement criteria.
Right, right.
So that is a consequence. That's a consequence. Now, and BCA guidelines now say very clearly already. Even though they don't, the code don't limit you, right? The BCA is going to limit you. You are required to do more testing on the concrete. That means you need to do more sonic coring to prove that the concrete actually achieved the strength.
Right, right. Yes.
Okay, you can, there is a circular going on before. I have the circular, okay? I read it before.
Right, yeah.
So you need to have more testing. That's one for sure. And also, they also limit you, if I'm not wrong. The BCA now also limit on the structural capacity of the pile. Okay, not say limit lah. They don't recommend you to use such a high strength anymore. Okay, on a case by case basis. If your ground is very good, okay, your ground is very good. That means that even with increase in structural capacity, you do not have to go up to 60, 70 meter kind of pile length. Then you have a chance. But if your, let's say in a rock socketing, right? In a rock socketing. Just now I asked this question, right? Can end bearing higher than the concrete strength? It can. If you have an end bearing higher than the concrete strength, means what? Your concrete will crack first before the rock fail, right? You got what I'm saying? So yes. In your case, you increase in cases for you want to have a high structural capacity and don't want to have a deep penetration length. The only scenario you will face is you have a very good soil condition. Your SPT 100 must be very near to ground surface. Your maximum pile length probably about 30 to 40 meters. Then you got a chance that you do not have this. Right. Okay, so that is my response to you.
Thanks.
Okay, yeah.
Thank you.
Any more?
Any more question? I have a question.
Who? Can you speak louder, sorry?
I have a question, Mr. Lim. I'm Joel. Just now I answered one of your questions. I'm a PhD student.
Oh, Joel. Yes, Joel, come.
Yeah, I would like to ask you, just now you mentioned that for Eurocode, typically the pile length is will be shorter. So I just want to ask you your opinion. Do you think that there's a disconnection between testing of pile and design of pile in Eurocode? Because testing of pile is still done based on number of times of working load. Would that actually give a problem most of the time? And is that the motivation why the model factor of the pile design has been revised from originally was 1.2 and 1.4 to 1.35 and 1.55? Thank you.
Okay, very good question, Joel. In the practical example, I will address this question.
Okay, thank you.
Okay. Any more?
Yeah, I do have a question.
You are, sorry?
My name is Gerardo. I'm working as a designer. I'm also doing a PhD at NUS.
Okay, you are you are a consultant also, right? But you also study for PhD, yes, right? Okay.
Correct. Actually, I think that you replied this question before, but I missed this part.
Your name is still under Norina Buang. What's your name again? Sorry.
Gerardo.
Jeda. Okay, Jeda. Okay, come.
Basically, I think that you replied this before, but when you were discussing about the working load test and the settlement criteria on the CDC here in Singapore,
yeah,
you mentioned about the short-term settlement criteria of 15 millimeters, and then you mentioned about the working load test settlement criteria of 7 millimeters. So I wanted to ask you, what do you think about the disconnection between these two settlement criteria?
Okay. For those of you who are not clear what Mr. Jeda is asking, I will just say that he's asking why BCA guideline is 15 and 25, why LTFs put 7 and 14, right? What is the different criteria? Actually, many of y'all cannot understand that LTA is a developer. Okay, it's a developer. They are not the regulating authority. Meaning what? So meaning LTA is no different from capital land, from HDB, or whatever developer you are working with. LTA CDC requirement is a developer requirement. It cannot overrule BCA, which is the regulating authority. But as a developer, I can impose a more stringent criteria than the authority because I want a higher quality of work. Don't ask me why they want to choose 7 and 14. Okay? My answer to you is that they want to have a more stringent criteria so that they do not want to have, that means they want to have more safety factor. I think that will be easier to answer you. While it's very uncommon for developer to impose a more stringent criteria than authority because it will mean more cost, but LTA is different. Okay, LTA, because we are dealing with public infrastructure, the consequences of a failure, even though it may be a serviceability limit failure, the remedial cost is higher compared to a high-rise building that is developed by a developer, a private developer, or even by HDB. Okay, so there's actually there's not supposed to have any connection. You don't need to say that why there's a disconnection. You don't need to understand why, because if you do the owner give you a set of criteria to follow, you just follow. As long as it don't deviate from the regulating authority requirements. Is that clear to you, Mr. Jetta?
I think so, but at the same time, in the LTA CDC, it is specified the 15 millimeters for short term, and in the same code, it is specified the 7 millimeters for the working load test. So even I think that what I'm trying to say is that even in the same code, there is a disconnection. I'm not even talking about BCA and LTA. I'm just talking about LTA CDC.
Okay, so you see, I understand where you're coming from. In LTA, that clause 7 mm, 40 mm, they are talking actually about the testing criteria. Okay, when you test,
correct.
If you got 7 mm, I will consider it, you fail the service limit. The 15 and 25 mm is actually when you design for it, they allow 15, 25. Okay, so the test requirement, they set a more stringent requirement for the testing requirement. You get what I'm trying to tell you? But in the actual performance, when you assess, let's say this structure, your viaduct already built long time ago, right? Then somebody go and do some work near to this viaduct that may cause some settlement, right? So, and this settlement they given to you is 15 to 25 mm. Okay, they allow this building to go through a 15 to 25 mm from short to long term kind of settlement. But in the testing, they don't allow you to go to the extent. I think that is my interpretation. I may be wrong, but that's what I think. So in short, they want, because in your testing, it's supposed to be in the most tip-top condition. You prepare the test file more carefully. I'm telling you, most piling contractor will take special care of the test file to make sure the pile don't fail one. But for the rest of the pile that don't pass, I cannot guarantee that. Okay, so that is I think that is more on the practical aspect on the QA QC side. That's how they control the quality control. Okay, so that's my take. I don't have other explanation for that, unless you want to go and ask the people who write the code in LTA. Or you ask Dennis. Dennis is going to ask Dr. Jaya. Hey, you going to ask Dr. Jaya why he write the code like that?
I have no idea.
Thank you.
Yeah.
Actually, in the CC, they allow you to have some more relaxation of the 7 millimeters, but I still wanna try to find out all this clause of 7
Okay,
millimeters.
but never mind. I have to stop the question now. Let's go.
Thank you.
Let's go to the real practical example. Okay, now